All right. We are going to talk about lines that are parallel versus perpendicular and what those equations look like. Okay, so remember, parallel lines are lines that never cross. Okay, so I'm going to go back for a second. So when you have parallel lines, they never cross. Okay, so you may have something that looks like that. Okay, so if lines are truly parallel, they are going to have the same slope. Okay, and then we have also what's called perpendicular lines. Okay, and so those might look like this. So not just that they cross, but that they actually cross at a 90-degree angle. Okay, so their slopes are opposite reciprocals. Okay, so opposite reciprocal slope. And basically what that means is if my slope of one line was 3/2 and they're truly perpendicular, the slope of the other line will be negative because that's your opposite. Reciprocal means to flip, so -2/3. Okay, those are opposite reciprocals. And if they have those type of slopes, they are considered perpendicular. Okay, so let's look at your notes page. Let me get to, I want to do parallel first. Okay, so this says are the lines y equals 2x plus 3 and y equals 2x plus 5 parallel. Okay, here's those lines graphed. Actually, that's not those lines graphed because that is not those, but these would be parallel because they have the same slope. Okay, so yes, the lines are parallel because they have the same slope. Okay. All right. So let's take a look at some of these example problems down here. So I'm going to do example 1 and 2 on this page, and then we're going to talk about perpendicular. It says write the equation of a line that is parallel. So keyword here, it must be parallel, meaning it must have that slope that passes through the point 62. This is kind of what we've been doing all along. Okay, what we need to know is another line. So I need another line with the same slope, but I need a different y-intercept. Okay, so I'm going to use this point as my x and my y. I'm going to keep the slope of 2 because it's parallel. I'm going to plug in x and y and solve for a new y-intercept. Okay, so my y is 2. My x value is 6 plus b. It's 2 equals 12 plus b. Subtract 12 from both sides. Okay, and that's going to give me b equals 2 minus 12, which is -10. Okay, so that line that would be parallel will be y equals 2x minus 10. So the original one was 2x plus 3. This one is 2x minus 10. They have the same slope, but this one also goes through the point 62. All right, and then let's look at example 2. All right, write the equation of a line that is parallel. Okay, so it's got to have that same slope that passes through the point 2, 6. So that's my x, that's my y. So I'm going to start with y equals 1/2 x plus b. I need a new y-intercept. I want them to be parallel. So my y value is 6. 1/2 times my x, which is 2, plus b. Okay, 1/2 times 2, that's 1. So subtract 1 from both sides. Okay, and 6 minus 1 is 5. So my line that's parallel, okay, remember it will have the same slope, but I found my y-intercept. Well, it says my y-intercept here is 5. Well, that doesn't really work, okay? These really aren't parallel, okay? Those are actually the same line, but this is the process and how to do your problem. And so I want you to do these next two before you, so like pause your video, do those two, try them out, and then go to the back of your paper. All right. So now we're going to talk about perpendicular. Okay, so it's wanting me to go through each of these and do a negative reciprocal. Okay, meaning basically your opposite reciprocal. Okay, so I would change the sign of this and I would flip it. So it would be negative 2/3. Okay, if you just have a 5, you can treat that as 5/1. That will change to negative 1/5. This one's already negative, so when I change it, it's going to be a positive. And when I flip it, 2/1, that is just 2. Okay? All right, so just taking a look at these two pictures. Focusing on the slope here. So I have right here a positive 2, and I have right here a negative 1/2. They are opposites, and they are reciprocals, meaning they are flipped. So these are truly perpendicular because they cross at a 90-degree angle. Okay? If one of them is just a 2 and one of them is a negative 2, these are not reciprocals. Okay? So if they're not true reciprocals, then they're not parallel. I mean perpendicular. Not perpendicular. Okay? All right, so let's look through this first example. Okay, write the equation of a line that is perpendicular to this graph. So I'm going to underline that slope for a second. Okay, that current slope is -5. I need the opposite reciprocal of that. Okay, so the opposite sign would be positive. The reciprocal of 5 would be 1/5. Okay, so I want an equation that's going to be perpendicular. So I've already flipped and found my new slope that passes through the point 10, 6. Okay, so I'm going to start here. So y equals 1/5x. So when it says perpendicular, change the sign, flip your number, then do the rest of the problem. Okay, my y is 6, x is 10, so 1/5 times 10 plus b. 1/5 times 10 is 2. So 6 equals 2 plus b. I'll write that right here as well. So now I got to subtract 2 from both sides. And that is my y-intercept. Okay, so my perpendicular equation will be 1/5 x plus 4. So repeating this step, opposite, negative to positive, and you flip it, 5/1 turns into 1/5, and the new y-intercept. So let's take a look at the second example. All right. So write the equation of a line that is perpendicular to y equals 1/2 x minus 6 that passes through the point 64. Okay, so here's our slope. My slope is 1/2. I have to do the opposite. So it's positive, so now it's negative. Flip 2/1. -2 divided by 1 is just -2. So this is still x and y. So y equals -2x plus b. My y value is 4. Keep the negative 2. My x is 6 plus b. So 4 equals negative 12 plus b. Add 12 to both sides. 16 is your b. Okay, so my perpendicular equation is negative 2x plus 16. So going back to make sure I did everything good, I had a positive, it's now negative. I had 1 over 2, it turned into 2 over 1, which is negative 2. So my slope is negative 2x, and I found my new y-intercept. Okay, I'm going to leave that last example up to you.